This is Algebra 2, Unit 9, Rational Functions, and this is Lesson 1, Simplifying Rational Expressions. So we're going to start this unit out with a little bit of review. One thing you need to remember is that a rational number is any number that can be written as a fraction. So if you have a rational expression or an algebraic rational expression, you just have a fraction that involves variables. Here, when we have something like this where we've got 32 over 24, I'm going to simplify the numbers first. 8 goes into 32 and 24. It goes into 32 4 times. It goes into 24 3 times. And then we have 5 x's on top, 3 on the bottom. So we're going to subtract the exponents from each other since the bases are the same. We subtract the exponents. 5 minus 3 is 2. There are 2 left over. And we put the 2 leftovers where the number or where the exponent was the highest. So we have x squared left over on top. For this one, we've got 15 over 45. 15 goes into both of those. That would be 1/3. And then there are no a's on the top, so that a to the 5th just comes down to the bottom. In the next one, we'll have to simplify this by factoring the top and the bottom if they will factor. So we're going to look at this. Are there factors of 10 that subtract to get me 3? Yes, that would be 5 and 2. And we need a plus 5 and a minus 2. That tells me the signs are different. The plus goes with the big number, the 5. And then on the bottom, are there factors of 15 that add to give you 8? That would be 5 and 3. And the plus tells me they're the same sign as what the middle sign is, so they're both pluses. And so the x plus 5 cancels. Remember, when you're simplifying a fraction like this, a common mistake is for people to try to simplify, like they'll cross out the x squared and the x squared, and they'll cross out the x's, and then they'll say 3 minus 10 is 7, and 8 plus 15 is 23. That's completely wrong. There's nothing mathematically right about that. But I've seen students try to do that before. The only way you can cancel out things that have factored is if those factors are attached with multiplication. You have to have multiplication over the division. You cannot have things attached with addition and subtraction and expect them to cancel out. You are going to cancel entire factors at the same time. You cannot factor, like here, we have the x minus 2 over x plus 3 left. You cannot factor out the x's. That's completely wrong. If it's attached with addition or subtraction, you have to keep it. There is no way to cancel those out. So the only way to cancel when you have a rational expression is if you make factors out of what you had and cancel entire factors. Here I have 3 more examples. In this one, I'm going to try to factor the top and the bottom. 6 times 3 is 18. Factors of 18 that subtract to give you 7 would be 9 and 2. So I need to make a 9 and a 2 out of the 6. The factors of 6 are 1 and 6, 2 and 3. 1 and 6, 1 goes into both of those, but 6 doesn't go into either one. So you can't use 1 and 6, so that means I'm going to have to use 2 and 3, 2x and 3x. And then 2 times what gives me the 2, that would be 1. 3 times what gives me the 9 would be 3. This minus tells me they have different signs, and the big number gets the minus, so the 9 gets the minus. The 3 times 3 makes the 9, so that would be a minus 3 and a plus 1 to give me the factors. And then I could check, is 3 times 1 3? Yes, it is. So we know we've got the factors in there correctly. For this one, 3 times 4 is 12. Factors of 12 that subtract to give you 11, well, that's 12 and 1. So to make the 12 and 1, 3 only has 2 factors, 3 and 1. So we've got 3x and 1x. 3 times what gives me the 12? Well, that would be 4. And 1 times what gives me 1 would be 1. 1 times 4 is 4. The minus tells me these have different signs. The big number gets the minus, so the 12 is the big number, so 3 times 4 is 12, so that gets the minus, and the plus goes in front of the 1. And then we're going to cancel a factor that they both have in common, and the common factor here is the 3x plus 1. So we've got 2x minus 3 over x minus 4 as my final simplified answer. In the next one, I'm going to also try to factor this one. This one's a little bit different because it's not a trinomial, but we can factor here. We can take out a 2x. When I do that, I have a 3x plus 2 left. And then on the bottom, nothing factors out of that. I just leave that as a 4x squared. And then the 2x and the 4x can cancel. 2 and 4 cancel to 1/2, so I've got a 2 left on the bottom. And then an x over x squared, we have 2 x's on the bottom, 2 minus the 1 on top leaves me with 1, and the leftovers go on the bottom. And then the top is 3x plus 2. Understand here, the 3x is attached to the 2 with an addition. The x's cannot cancel out because this x, even though it's attached with multiplication, the top one is attached with addition, so you can't cancel that out. For this one, the top is difference of squares. 3x is the square root of 9x squared, and 2 is the square root of 4, so we've got a 3x plus 2 and a 3x minus 2 to factor that difference of squares. Here I can bring out a 3x. So when I bring out a 3x, I have a 3x left minus 2 on the inside, and then my 3x minus 2 is a common factor, so it can be canceled out. And that leaves me with 3x plus 2 over 3x. It is tempting here to try to cancel out the 3x, but remember, this one is attached with an addition sign, so you cannot cancel those out. That would be your final answer. That's all you can do.